In chemistry, when we do unit conversions, we use a process known as the factor label method. You might have learned other ways of doing these conversions, setting up proportions, or another method, but we really want you to learn this factor label method in this class. So do make sure that you follow the directions for this method and you learn how to do them, because eventually some of the other methods usually break down when you're trying to do conversion after conversion after conversion, while the factor label method is quick and easy, and if you get the units lined up right, will always give you the right answer. So the factor label method basically uses this type of a thing. Okay, we use starting amount, we multiply it by some type of conversion factor, and we get our desired amount. Now the key here is the conversion factor. And we're going to use a little fact of algebra to help us out with these, figuring out which conversion factors to use at any specific time. Let's go through an example, which might make it the easiest way of handling this. So here's an equality. It changes pounds, which are labeled as LB, or this number sign, that's a sign for pounds. And we know that 1 pound has 453.6 grams in it. So from this equality, we said we could make 2 conversion factors. We can put the 1 pound on top and the 453.6 grams on the bottom, or we could put the 453.6 grams over the 1 pound. Now the question is, when do we use one and when do we use the other? And I think you'll see this when we do an example. So our first example, it says convert 381 grams to pounds. So it's asking how many pounds is that? So you're going to start off with the thing that's not the conversion factor. The thing that's not the conversion factor in this problem is the number of grams. So we're going to start off our problem with that number, 381 grams. Now we're going to multiply it by a conversion factor to get our answer. Now we're going to use the fact that when we do these conversion factors, we leave the units in. Okay? That's very, very important. That's a key point in this method. You have to leave the units in. And we know that if we have, for example, an algebra problem, if we have 5a over a, the a's can cancel out, right? Same thing on the top, same thing on the bottom, they can cancel out. Well, we're going to do the exact same thing, and we are going to use the units and keep them in our problem. And if the unit is on the top and the unit is on the bottom, they will actually cancel out. So instead of just doing a multiplication sign, I'm going to use this little grid. Everything on the top gets multiplied, everything on the bottom are the things that get divided. So if we have grams on the top, we need grams on the bottom in order to cancel it out. So we're going to put the grams on the bottom, and that means the pounds have to go on the other side of the line. And that's what we're going to end up with in our answer. So then we have to figure out which conversion factor do we use. Well, it's this one right here, the one with the grams in the bottom. So we're going to put that conversion factor in with grams on the bottom and pounds on top. Now when you go to look at these, we first are going to cancel out units. Grams on the top cancels out with grams on the bottom. The only unit we haven't canceled out is pounds. And that is going to be the answer, because we carry all the units through to the very end unless they've been canceled out. That is what we want. So by doing this, we can also use these units as a double check that we did the math right. If we don't get the right units at the end, then probably we messed up somewhere in here. Okay? So this math will give us exactly what we need, the number of pounds. Now, don't forget, you're going to need a scientific calculator. This is what my scientific calculator looks like. And we're going to just type these guys into our calculator. You'll become very familiar with your calculator by the end of the semester. So we've got 381 times 1 divided by 453.6. We get our answer, and our answer is 0.83994709. This is what comes off the calculator. And now we've got to ask one question. And this question we're going to ask every time we do a calculation. And that is, how many significant figures? What's the significant figures? And we ask that question before we move on to the next problem, because our final answer has to be the correct number of significant figures. So we're going to go back to our original numbers and look at the significant figures. This is multiplication division, so we're going to use the multiplication division rules. This one has 3 significant figures. This one has 1, 2, 3, 4 significant figures. And the 1 is an exact number. So it could have as many significant figures as you want. That's really like 1.00000. Because it is an exact number, so we don't count it for significant figures. Okay. So we've got something with a 3, something with a 4. So the lowest number of those is 3. So our answer has to have 3 significant figures. So we're going to look at this. The leading zero is not significant. So if we need 3, this would be significant. The 3 would be significant. And the 9 would be significant. So now we have to round. Remember, we have to go to the one to the right of where we want to round. This 9 is above 5. So we're going to round it up. So the 39 here has to become 40. We end up with 0.840. Don't forget the units. Numbers are meaningless without the units. So make sure you get the units in there. 0.840 pounds. And that is our final answer. Okay. So this process of starting with our starting amount, using a conversion factor to make the units work out to get the final answer is called the factor label method. We're going to do a few of these so that we make sure that we understand them and that we can do them on your own, and then you can work on them in the homework as well. Let's do another example. Go ahead and move this down so that you can see our next example. Our next example says we've got 2,000 grams, and it's asking us how many kilograms is that? Okay. Now, you'll notice that in our first one, we were using British units, English units, the pound. So I gave you the conversion factor here involving pounds, because we said we didn't have to memorize the English system. The metric system, on the other hand, you have to have memorized. So with this conversion, I didn't give it to you. As you're doing the problems and getting started up, you may not have these memorized yet. So you can go ahead and use your book to find those conversion factors. But do keep in mind when you get to an exam or quiz, you have to have these memorized for the metric system. So the conversion factor of grams to kilograms is what we want. So if we remember, King Henry doesn't bother drinking chocolate milk. Here's kilo. Here's our basic units. 1, 2, 3 jumps. So there are 1,000 of the little guys, which are the grams, in one of the big guy. This is our equality. That's what we're going to use as conversion factors. Remember, we can get 2 conversion factors out of that. We can have 1,000 grams in 1 kilogram, or we can have 1 kilogram in 1,000 grams. Okay. We're going to decide which one we need based on how we set up the problem. All right, let's go ahead and set up the problem. We're going to start with the thing that is not the conversion factor. So it's basically the 2,000 grams. And we'll put our little grid in here. Grams are on the top, so we need grams in the bottom to cancel out. So which conversion factor are we going to use? Well, we're going to use this one here that has the grams in the bottom. So we have 1,000 grams in 1 kilogram. And so we'll look at our units, cancel out grams, cancel out grams. The only units left are kilograms, and they're in the top. That's what our answer is going to be. Before we do the actual math and plug things in the calculator, let's double check to make sure is kilograms what we were looking for? Yes, it is. So because that agrees, we know we're on the right track. Let's get our calculator. We've got 2,000 times 1 divided by 1,000, and we end up with 2 kilograms. Now I mentioned that every single time before we move to the next problem, we have to ask a question. Does anyone remember what that question is? Significant figures, absolutely. So let's go ahead and look at our significant figures. Here we've got 2,000. There's no decimal place here, so the zeros are not significant. So this actually only has one significant figure. The numbers in a metric conversion are exact numbers, which means that they don't influence our significant figures. So we've got basically one significant figure in the numbers we're multiplying, and so our answer needs one significant figure, and in fact 2 kilograms, that has one significant figure in it. We're going to do one more example, and I'll just down a little bit further so that you can see. And our next example converts, we're going to convert 1.8444 gallons, and we want to know how many milliliters there are. Now, gallons is not a metric unit, so we can give you, you'll be given some type of conversion factor for that. And the conversion factor is 3.785 liters equals 1 gallon. Okay. Now in this problem, we're going to show you how you can actually stack conversion factors, which means you can put more than one conversion factor in the same problem in order to get to the answer that you need. Okay. So we're going to start off with the thing that's not a conversion factor. So that's basically our starting number there. It's 1.8444 gallons. Okay. Put our little grid up here. Gallons is the top. So where do gallons have to be to cancel out? They have to be in the bottom. So we're going to put our gallons here from our equality, 1 gallon. And then we're going to put the other thing on the other side of the line, 3.785 liters. That's our conversion factor. So you can see I didn't write them out this time on the side, both of them, flipping them back and forth. I just used it directly from the equality. And I knew that gallons had to be in the bottom in order to cancel out with gallons that's in the top. Okay. Now, if we finish this problem right now, we would get liters as an answer. Equal sign, we'd end up with liters. We have to ask ourselves, is liters what we were asked for? No, we were asked for milliliters. So that means that we're not done yet. Okay, something's not quite right. You have to keep working at it. So the key thing to notice at this point is that liters and milliliters are metric conversion. And we know that we can go through King Henry doesn't bother drinking chocolate milk. We've got 1, 2, 3. That's a factor of 1,000. So we have 1,000 of the little guys, milliliters equals 1 liter. That is a metric conversion factor, or metric equality that we can use as a conversion factor. And that one you should have memorized for the exam. So we're going to have liters in the top here. We need to put the liters in the bottom in order to cancel out. That means we put the 1,000 milliliters on top, liters in the bottom, milliliters on top. Now let's double check our units. Gallons cancels out with gallons, liters cancels out with liters. The only unit in this whole thing that we didn't cancel out is milliliters. So our answer will be in milliliters. We'll double check our units to make sure we're on the right track before we plug it into the calculator. Milliliters here, we were asked to solve for milliliters, so they do agree, so we know we're on the right track. Let's get our calculators out, and let's put in 1.844 times 3.785 times 1,000 divided by 1 divided by 1, and we get our answer of 6,9. Oh, hold on a second. 1.844 times 3.785 times 1,000. 6,979.54. That's what the calculator said. Now, we are not through yet. What's the one question we have to ask before we move on to another problem? Significant figures. You've got it. So let's do our significant figures. This number at the beginning has 1, 2, 3, 4, 5 significant figures. The 1 is an exact number, so that doesn't influence our significant figures. This number has 1, 2, 3, 4 significant figures. And the metric conversions are exact numbers as well. So we've got 5 significant figures, 4 significant figures. 5 and 4, which one's smaller? Well, the 4 is smaller. That means our answer needs 4 significant figures. Okay. So we're going to do that. Let me write this up here so that I can get to the 4 significant figures. We can get to the number. We're going to start on the left. Here's 1, here's 2, here's 3, here's 4. So the ones place is as far as we can go and have the right number of significant figures. So let's look at the place to the right of that to determine if we round up or down. This is a 5. So we're going to actually have to round up. So 79 has to become 80. 6,980 milliliters. But if we write it like this, is that correct? No, because writing it like this, that 0 at the end is not significant. So to make sure that we have 4 significant figures, we need to make sure we put that decimal point there. Okay. Don't forget the decimal point. That's part of the answer to ensure that you have the 4 significant figures. So there is a tutorial online in the modules folder on Canvas. You can go to modules and then look for unit 1. And in the review material, there is a tutorial on the factorial method. So if you're having difficulties with any of these problems, look at that tutorial, see if that helps you out as well. Also, don't forget on your online homework in OWL, it also has tutorials in there. So do make sure you take advantage of them. And if you have questions, email me so that we can get you set up. We also have tutoring that you can sign up for, which can help you learn some of these math concepts. in more detail. So if you're struggling with the math, do take advantage of all those resources. And the main thing here is to get onto OWL and then do some practices.